Hello mathematicians, puzzlers, and other curious people. In this video we're going to talk about associativity, which is the ability of numbers to be combined in varying orders. So to have two of them going first or a different two of them going first out of three. So here are some examples. Once again, some operations are associative and others are not. We can start to check on that by looking at some examples of different numbers with different operations. So I'm just going to keep it really simple at first. I'm going to try 1 plus 2 plus 3, and I'm going to make sure, although this is what would happen anyway because of the way the order of operations is agreed on to work, I'm going to emphasize it by using parentheses. So that's 1 plus 2, and then further plus 3. We got 6. Now I'm going to try doing something different. I'm going to try doing 1 plus the sum of 2 and 3. Once again, I get 6. GeoGebra helps me out a bit with this. In a way, it takes off the parentheses. Some calculators will do that in their display and some will not. It doesn't matter. So we can suspect from this that addition might be associative. What about subtraction? Let's find out. So what about if we try to subtract 5 minus 3 and then from that minus 1? Well, we get 1. But then what about if we do 5 minus the difference, 3 minus 1? That time we got 3. So clearly subtraction is not associative. Subtraction is grouping sensitive. Okay, now how about multiplication? First I'm going to multiply 2 times 6 together, and then I'll multiply that by 5, and I get 60. Now I'm going to try multiplying 2 times the product, 6 times 5, and I get 60 again. So multiplication based on this, it seems like, could be associative. Let's try division. So what if we have 12 divided by 4 that we then further divide by 2? Okay, so we get 3 over 2. Well, what about if we have 12 divided by the quotient 3 divided by 2? We get 8. So in one case we get 3 halves, in the other case we get 8. That's definitely different. So division is order sensitive. Now last but not least, exponentiation. So what if we have 2 to the power 3 to the power 5? Okay, 32,768. Now on the other hand, what if we have 2 to the power and then grouping these second two together, 3 to the power 5? Whoa! So I think it rounded. That's definitely different. That's a much larger number. Okay, exponentiation is definitely order sensitive. So we've got two possibilities here, addition and multiplication, of operations that might be associative all the time, no matter what three numbers we use. Now remember, we are not going to try all possible combinations of three numbers because we'd be here forever. But I want to think about some things that could help us figure this out. So once again, I'm going to think about addition as a pile of rocks and multiplication. Now this time we're talking about three numbers, so 3 dimensions. So instead of a table that's flat, I'm going to think about a box. So for addition, I'm going to think about 3 piles of rocks. And for multiplication, instead of a flat surface like a table, I'm going to think about a 3-dimensional object like a box. So let's suppose that we have 3 piles of rocks that we're going to put together. Well, if we collect up the first 2 piles and shove them together, and then move the third pile of rocks in with them, we have a certain amount of rocks. Now on the other hand, if we collect the second and third pile of rocks together and shove the first pile in with them afterward, we still have the same rocks. So we have to have the same number of rocks. So yeah, I would say addition is always going to turn out to be associative. So if we take our first 2 numbers and add them, and then add a third number, or on the other hand, if we say, okay, let's take that first number, but to that we add the result of adding the second and third number, we expect that that should always come out the same because of what we know about pushing together piles of rocks and how that's like addition. So our example here was that 1 plus 2 and then plus 3 comes out the same as 1 plus the sum of 2 and 3. Now multiplication is a little bit trickier to think about, but what I want to think about here is an object with 3 easy to measure dimensions that we would calculate the volume of by multiplying a ordinary basic box. So we would calculate by multiplying together the length and the width and the depth of the box. So we could say, well, it's like we're multiplying together the length and the width. So we're calculating the area of the base and then multiplying that by the depth of the box. And that's fine. But what if we rotate the box so that then the width and the depth side is the base? So we just kind of turn it this way. And then we measure those, multiply them together, and then multiply by what we had been calling the length. Well, it's still the same box, so it has the same volume. So definitely, if we multiply the first two numbers together and then by a third number, or if we rearrange by multiplying that first number by the product of the second and the third number, we should get the same result because those could be the dimensions of the same box. And the example we did was that 2 times 6 and then times 5 comes out the same as double the product 6 times 5. So that's what associativity looks like with examples, formulas, and reasons why it works in the form of rocks and boxes. That's what you need to know about associativity to deal with most math problems. So for now, calculator.